So get this, the Earth acquires 40,000 tons of mass every single year. More and more people are being born, new buildings and structures. You might think that's something that adds mass, but nope, since it's created out of existing matter on the Earth, it's actually dust falling from space to our planet. That dust consists of vestiges coming from our solar system, like space bodies that never managed to form into a planet, or asteroids and meteors that fell apart on their way and now drifting around. Our planet is there like a giant vacuum cleaner that pulls in all those particles of dust powered by gravity. So yes, Earth gains weight, but some calculations also say the entire planet, including the atmosphere and the sea, is losing around 50,000 metric tons of its mass annually. Gases like hydrogen and helium are within our planet's atmosphere, but they're so light gravity can't retain them there. So huge amounts of those gases escape our planet every year. 6 pounds of hydrogen every second. Sounds like a lot, but the Earth is really heavy, so it would take trillions of years for all the hydrogen to escape our atmosphere. Also, the planet's core is like some sort of big nuclear reactor. It runs all the time, so it gradually loses energy, which means it's losing mass too. Our planet is not a perfectly shaped sphere, it's more like a squashed one. As it spins, gravity is directed toward the Earth's center, while a centrifugal force goes outward. Earth has a tilted axis, so centrifugal force doesn't exactly oppose gravity. Also, gravity pushes those extra masses of Earth and water up at the equator into a bulge. Earth also has a waistline, 24,900 miles. You weigh more standing at one of the poles than at the equator. Although, for weight loss, Pluto comes as the best option. A 150-pound person would weigh around 10 pounds there. Avoid Jupiter, the same person would weigh over 350 pounds there. Our planet is all green and blue now, but chances are it used to be purple. Scientists think ancient microbes might have used some other molecule to harness the sunlight instead of chlorophyll that gives plants their green color. That molecule possibly colored the living organisms into a more violet shade. The Earth is electric. Just one stroke of lightning can heat the air to over 50,000 degrees Fahrenheit, which causes the air to rapidly expand. That same ballooning air makes a shock wave we know as thunder. 6,000 lightning flashes appear all over the planet every minute, and the longest one occurred in the sky above Brazil, 440 miles long. Newer studies found out that the Earth's core is as hot as the sun's surface, over 9,300 degrees. The driest spot we have is the Atacama Desert of Peru and Chile. The center of Atacama has spots where we've never recorded any rain. The coldest place is naturally Antarctica, where winter temperatures can go down to minus 100 degrees Fahrenheit. No thanks. It's also the biggest desert we have on Earth. We imagine deserts as endless, sandy, and insanely hot areas, but there are coastal, subtropical, and polar deserts. They all have wind-swept and barren lands, which makes them very difficult for animals and plants to inhabit. The Pacific Ocean is the Earth's biggest ocean basin, which covers a huge area of almost 80 million square miles. The Pacific contains over half of the free water on our planet, and is so big all of our continents could fit there. Earth used to have 2 moons, or at least that's something scientists believe. That second one was almost 3 times smaller than the one we have today, and may have orbited our planet before it slammed into the bigger one. This clash may be an explanation of why the 2 sides of the moon we're left with is not equal. And there are moonquakes going on. It looks pretty inactive from our perspective, but the ground there is definitely shaking, although less than on Earth. Moonquakes shake at great depths, especially midway between the lunar center and its surface. To get to the longest mountain chain, we have to look way down under the surface of the Atlantic Ocean. It's a chain of volcanoes that goes about 18,000 feet above the bottom and spans over 40,000 miles. We have a magnificent planet, more than 4.5 billion years old, which makes it 10,000 times older than humans. But it's not the same as it was in the beginning. The ground we walk on is recycled. Earth has its cycle. Magma from the depths of our planet comes up and hardens into rocky matter. Tectonic movements brings the rock to the surface where erosion happens. That's a process where wind, water, and other natural forces break apart rock and changes it. Those small pieces get buried, deposited, and compacted into sedimentary rocks like sandstone. If these rocks are buried deep enough, they get cooked and transformed into magma, so the whole cycle repeats all over again. We got used to seeing lava and ash coming out of volcanoes, but some of them even produce their own flashes of lightning. In 2020, the Taal volcano, which is around 40 miles away from the Philippines' capital, Manila, started blasting smoke and ash pretty high into the air. Inside its ash column, small pieces were colliding and then producing lightning flashes people could see scattering across the sky. Lakes can go crazy and explode too. Neos, Manoon, and Kivu are 3 lakes that sit above volcanoes. Since there's magma under their surface, there's carbon dioxide released into the lakes, which leads to a deep gas layer above the lake bed. It's pretty rare, but carbon dioxide can suddenly erupt from the lake and form an unpleasant gas cloud, similar to something a volcano does. 70% of our planet's surface is covered in oceans, but we've only explored 5% of them. And around 300 million years ago, I wasn't around then, we only had one massive supercontinent called Pangaea, with one huge sea, Panthalassa. Surprisingly, coral reefs are the biggest living structures. They consist of small coral polyps, but together they make a true community of organisms and a very important part of Earth's ecosystem. Some coral structures can even be seen from space. The Earth's surface is not evenly shaped, which means mass is uneven too. That way, gravity is not the same in all spots on Earth. There's a mysterious anomaly in the Hudson Bay of Canada. The gravity there is lower than in other regions surrounding this area, and scientists believe it's because of melted glaciers. During the last ice age, that region was covered in ice, which is now long gone and melted. But the planet hasn't completely recovered from the icy burden. Gravity over any area is proportional to its mass. The glacier left an imprint that pushed aside a part of the planet's mass, which is one of the reasons why the gravity is weaker in that area. Some bugs get nastier when in space without gravity. Studies showed some bacteria, like Salmonella, can make worse damage in space because there's something in the lack of gravity that makes them tougher and changes their activity. The days on Earth are slowly getting longer. When the planet was formed, days were about 6 hours long and gradually got longer. 620 million years ago, a day lasted 22 hours. Today, we have 24 hours, but it's increasing by around 1.7 milliseconds every century. This happens because of the Moon. It's slowing down our planet's rotation with the tides it helps create. When the Earth is spinning, tidal ocean bulges are pulled a little bit ahead of the Moon-Earth axis. That makes some sort of force that slows down the rotation of our planet, which is how our days are getting longer, but really slowly. We'll have to stick to our 24-hour schedule for a very, very long time. Earth's core certainly seems to be far away from us, but the distance is not that big, 1,800 miles. That's shorter than Route 66. The strongest earthquake we ever had was in Chile, a magnitude 9.5. If an earthquake ever reached magnitude 12, it could split our planet in half. Also, if there's an earthquake happening, it can hit more than 400 miles under the surface, which is why people on the other side of the planet can literally feel that. Our planet has around 100 million times more individual viruses than there are stars in the universe. Clouds are not some fluffy things whose shapes we sometimes like to watch. They actually help regulate the temperature of Earth. If we could pull out all water droplets in clouds and bring them to the surface, that would cover the planet with a liquid film as thick as a human hair. And yet, such a small amount of water brings enough differences with the weather and climate. Our planet would be 13 degrees hotter if it weren't for clouds. Wow, the great day is finally upon us. The record-breaking hole-boring team is finishing their job today. Spectators have gathered from all parts of the continent just to look at the greatest borehole in the world. And even the Guinness World Records Commission is officially dumbfounded. The hole is more than 1,000 miles in diameter and goes almost as deep as the Earth's core. No one achieved this depth before. But wait, what's going on? People all around suddenly begin fainting. More and more of the spectators fall unconscious on the ground, their faces white. Did the diggers hit some dangerous gas pocket? Oh no! We're getting messages from all over the world that people start falling just where they stood. What in the world is happening? Ugh. So, this is the scenario you get if you dig a hole in the ground deep and wide enough to fit the whole atmosphere inside it. Let's explore. The atmosphere goes really high up, getting thinner and thinner the higher you rise. For example, on the ground level, you can breathe freely, while on top of Everest, you won't be able to survive for long if you haven't had a good training course beforehand. The air on the mountaintops is much thinner, and so it's a lot colder and harder to breathe there. If you rise even higher, say to the altitude where airplanes fly, you probably won't be able to breathe at all. That's because they have oxygen masks on board. If the plane loses its inner pressure, the air from the outside will rush in. And since it's too low in oxygen for your lungs, you're likely to lose consciousness very quickly. All that doesn't mean our atmosphere ends there. In fact, it goes far beyond. And some scientists say it could even include all the distance to the moon and even further. Oxygen molecules from the Earth's atmosphere can be found at massive distances. Although there are so few of them, you won't be able to use them anyway. And the furthest range the atmosphere goes is almost twice as far as the moon. But those are no more than tiny specks of hydrogen at that point. Now, if we somehow compress all this volume into a relatively small bubble around the planet, it would be about 6 miles above the ground, roughly the height at which commercial airplanes fly. Any higher, and there's big cosmic nothing called vacuum, where no airplane would be able to navigate. Next step, fitting this mass of air into a hole in the ground. For starters, the entire volume of our rather thin bubble is only enough to fit into a 1,000-mile cube. This is just a little smaller than the Earth's core, and a side of such cube is about a third of the United States east to west. And here's the first serious problem. No one has ever dug a hole that deep, or wide for that matter. The deepest human-made hole in the world is the Kola Super Deep Borehole, and it's only going about 7 miles down. The drilling stopped because of unexpectedly high temperatures. Drilling and digging, though, are different things. The Kola borehole is only 9 inches in diameter, while what we need is to take a supermassive chunk out of the Earth to fill it with air. Still, at about the same depth, we'll face the temperatures of around 350 degrees Fahrenheit, and the deeper we go, the hotter it'll get. The Earth's core lies at 1,800 miles, so to dig that cube, we'll need to go more than halfway to the center of the planet, where the temperature will reach almost that of the sun's surface. And that's not considering the time we'll need to dig that deep. Anyway, let's assume we have the equipment that can withstand such heat. As we go down, the air fills the pit and slowly leaves the atmosphere. And as it gets deeper, the pressure on it grows too, making it take less space. In the end, with all that weight from above, we won't even need such a deep hole, right? Nope. The high temperatures in the Earth's innards makes the air less condensed and compensate for the pressure. If the surrounding rock is hot enough, it will expand the air to such a degree where it will take the same amount of space as on the ground level. And when it gets even hotter than that, well, the air will actually take even more room than we've calculated. But we diggers aren't that easily daunted. The experiment continues with an actual 1,000-mile cube dug in the Earth's surface, reaching into the crust and mantle and almost to the molten core. The air expands from the heat and starts taking up more space, resisting its imprisonment. That's why we begin digging to the sides at lower parts of our hole. To compensate for the air expansion, the additional hollows span over 4,000 miles. That's about the radius of the planet. Finally, the air seeps down, leaving the atmosphere and filling the internal parts of the Earth. And still it won't stay put. Some of the air is yet on the surface, and everyone can still breathe, although it's becoming much harder. Turns out, to fill the pit with air, we'd need to dig so much that the Earth would just fall apart before we finish. But even now, the enormous hole we've made has changed the planet's center of mass, and is now spinning and revolving around the sun more slowly and awkwardly. Instead of pushing all the air from the atmosphere down below, we've caused a cataclysm that would destroy our planet much more quickly than the lack of breathing air. Okay, so let's rewind then. We can't dig a hole in the ground because the air just won't fill it, but stubbornly spills out, and eventually our planet will just be torn apart. And we probably can't dig through the ocean's bottom because the hole will get filled with water instead, and the air won't have the room either. And that's not saying anything about all the water that gushes down to the hot layers of the Earth, causing catastrophic reactions that will, you guessed it, blow the world to pieces. If so much cold water reaches the extremely heated depths of the planet, hot magma below will start releasing toxic gases into the atmosphere, suffocating any life on the surface. Oh boy. So, the only chance to fill the hole in the ground we made is to compress the air to a liquid state, almost like they do with scuba gear. The oxygen tanks are filled with super compressed air that allows divers to breathe for a long time using just a small vessel. Now, we could just fill several 100,000 of such tanks with compressed air from the atmosphere and throw them all into the hole we've dug out. The pile will only be several hundred miles high, so technically it's not possible. Or we could invent a really huge tank for just this one purpose, pump all the air from the atmosphere in there, compress it as much as possible, and then dump it into the ground. Congrats! Mission accomplished! We've dug a hole deep and wide enough so that all the air around the Earth fits inside it. Now, what happens next is all life on the planet stops breathing. Humans, animals, plants, even aerobic microbes can't survive without oxygen. So everyone and everything is effectively wiped out. Then, no more oxygen means no ozone layer either. The lack of this natural barrier makes the planet extremely vulnerable to the sun's radiation and cosmic rays. The flares from the sun stop warming the Earth and begin scorching it instead. The surface of the planet rapidly becomes an arid wasteland, bombarded with heat and UV rays. Next goes tectonic activity. With the temperature outside spiking, volcanoes start erupting all around the world, making it a churning mass of hot lava. Oceans boil and evaporate, mixing with toxic fumes and creating a thick blanket of black clouds. Ash and acid fall from the sky, covering the already scarred Earth. And finally, our former blue and green planet turns into a twin sister of Venus, the unbearably hot and inhospitable place where no life is possible. Well, this would not be a smart thing to do. So please, let's not try this at home. You want a super big hole? Try the Grand Canyon.
Look at this spatula. Just a regular tool, mix and spread ingredients, right? But wait, this one is floating in space for some reason. So there's this astronaut named Pierce Sellers. There he is. He's up there in space, just doing his thing, when all of a sudden, he accidentally drops his trusty spatula. Let me give you some context. This all happened during the Space Shuttle Discovery's STS-121 flight back in 2006. They were on their way to the ISS on a mission to test out some new safety techniques. And now this spatula is just a tiny drop in the ocean of space debris. Humans have been exploring space for over half a century now. We've left all kinds of random stuff up there, from itty-bitty bolts to entire space stations. We've chucked a ton of things into the great beyond. Most of it burns up in a spectacular blaze as it re-enters Earth's atmosphere. But some bigger pieces can be a real danger for astronauts and their fancy spacecraft. Imagine accidentally crashing into a massive hunk of space junk. There are other weird things found in space. In November 2008, astronaut Heidi Stefanishan Piper was out on a spacewalk trying to fix a jammed gear on a solar panel. Suddenly, she lost her grip on the bag. That bag weighed around 30 pounds and was filled with all sorts of cool stuff, like grease devices, a scraper tool, and bags for debris. And it was pretty pricey for a tool bag. It cost around $100,000. Sometime later, amateur astronomers spotted the bag floating around in space. If you're in North America, you can even check if the tool bag is passing through your little slice of the sky. Just hop on over to spaceweather.com's satellite tracker and see if you can catch a glimpse of this interstellar tool bag. By the way, if you need to twist some wires in space and you don't have pliers, well, you may stumble upon them as they're free floating in space too. Back in the day, when astronauts were just getting their space groove on, they tended to misplace things up there. During his first spacewalk on the Gemini 4 flight in 1965, Ed White, a famous spacewalker, accidentally let go of his glove. That glove decided to have its own adventure and hung out in orbit for a whole month before getting roasted in Earth's atmosphere. So not all debris is there to stay after all. So, space junk is basically all the stuff floating around in space that humans have left behind. Before we got all curious and started exploring, there wasn't any space debris hanging around. Imagine space junk as a little kid who just learned how to walk and play with their own toys. When they couldn't walk yet, it was easy for the person watching them to keep the play area clean. They were in charge of taking out the toys and putting them away. But now that the kids can walk, they can grab as many toys as they want and make a huge mess on the carpet. Well, it's kind of the same with us humans exploring outer space. We've sent all sorts of cool gadgets, like cameras, rovers, and rockets to check out what's out there. But we haven't really thought about bringing them back to Earth. And that's where the problem comes in. All this space junk floating around could mess up outer space and even our planet. When we think about outer space, we often imagine vast open spaces that are yet to be fully explored. Humans have only discovered a tiny 5% of the universe. But here's something they might not always consider: the impact of all the cool gadgets they send out there. Believe it or not, as of May 2022, we've got more than 5,000 satellites orbiting Earth. Over 5,000 opportunities for these machines to go haywire, get lost in space, or even worse, create a bunch of debris that could harm both outer space and our lovely planet. There's at least 3,000 satellites just hanging around up there, not doing anything useful, and nobody seems to be bothered about bringing them back home. And what if one of these inactive satellites accidentally collides with one of the thousands of other space junk pieces orbiting our planet? It will result in a catastrophic disaster. We're talking about a crazy release of toxic substances that could wreak havoc on our poor Earth. Space junk can mess things up for scientists trying to make important discoveries. It's not just floating around aimlessly in space or posing a threat to Earth. It can hinder their chances of success. Even the moon has its fair share of junk, which Neil Armstrong definitely didn't encounter when he landed there in 1969. Think of it like this. Imagine you're an artist trying to create a huge painting. It's hard to do that if there's a bunch of old paints, brushes, and other stuff cluttering up your play area, right? Well, it's the same deal for scientists trying to set up camp and use new technologies for advanced missions and space exploration. They need a clean and organized space, just like you need a tidy work area. Otherwise, it's chaos. So here's the deal with space junk. It's not just about sending stuff up into the atmosphere. It's also about how far away we send it. You see, when satellites are sent over 22,000 miles into the atmosphere, it becomes a real problem to retrieve them and bring them back to Earth. And that leads to even more space junk floating around up there. Now, I know what you're thinking. How long will it take for space junk to become a major problem? Well, it might still be a few more years before it messes things up in outer space. But hey, that doesn't mean it's not a threat to satellites we have up there right now. Those poor guys are at risk of getting damaged, destroyed, or even leaking toxic stuff because of all that junk. So, space debris isn't just a problem for space exploration, but it's also a problem for us Earthlings, even though it's floating thousands of miles above us. Space junk is like that annoying neighbor who throws trash out their window and it ends up in your backyard. Except instead of trash, it's releasing all sorts of chemicals into our atmosphere that are slowly destroying our precious ozone layer. It can even ruin future space missions. Imagine this. You're all pumped up to launch a rocket into space, but nope, space junk decides to crash the party. Not only does it mess up the launch, but it also adds more pollution to our already struggling atmosphere. And if things couldn't get worse, imagine a shooting star or meteor accidentally smacking into some space junk on its way to Earth. Boom! Millions of toxic particles raining down on us, further depleting the ozone layer. Plus, space debris is becoming a real problem for space missions. In 2022, we found some space debris hanging out on Mars. The Perseverance rover stumbled upon its own back shell just chilling on the surface of Jezero crater. They also spotted a random piece of a thermal blanket that might have come from the rover's descent stage. Also, human-made space debris actually smacked into the moon in 2022. It was probably some old rocket body from the 2014 Chang'e 5T1 mission, but nobody saw that coming. It left a double crater behind. The more space junk we have floating around in low Earth orbit, the higher the chances of a cosmic collision. These collisions are no joke. They've already caused some serious satellite damage. Even the ISS has to constantly maneuver to dodge space debris. But scientists seem to know how to clean up this orbital mess. They're planning to send space vehicles armed with nets, harpoons, and even robotic arms to capture and deorbit all that junk.